Okay, part two of assessing significance. In part one, I laid out the first way of thinking about significance, which is statistical significance. In the second part, we'll look at the second way of significance, using the word more normally, the way you would use it in conversation. So in the second part, we're asking, how strong are my results? Are they really meaningful? So it's a different way of using the word significant. So B, I wrote, assuming that your results are not due to randomness, how powerful are they? How much effect does your independent variable have on dependent variable? Now we can measure this using delta. So the delta statistic has two uses. We calculate it the same way. It's the difference between the highest and lowest percentage in a row. So we can use it both to assess statistical significance. Is it greater than 10% or not? We can also use it just to measure how much effect the independent variable has on the dependent variable. So let's look at this table. Let's assume, well, this is not statistically significant, so let's use another example. Okay, I'm going to go back to the example looking at attitudes towards capital punishment and how they vary by sex. This question was only asked in the years 1972 and 73. I put a selection filter here in to select out only the year 1973. I'm going to go and in output options, remember you want to have a check where it says summary statistics, have that checkbox checked off so we get our p-values. Go ahead and run the table. There it is. The first thing I look at is the p-value. Is it great? Is it less than 0.05? Yes, it is. So I'm going to accept this table as statistically significant. Is my n less than 2,500? Yes, it is. It's only 1,417. So I know I can trust P. So this table is statistically significant. But is the difference between men and women meaningful? Again, we'll use delta to calculate that. So as always, I subtract the lowest percentage in a row from the highest percentage. And the difference between men and women, if I subtract 57 from 69, it's about eight points or so. Oh, I'm sorry. I was going to trim that, but I didn't. It's about, obviously, it's about 12 points or so, 12 points difference. So again, if I use delta as my measure of statistical significance, is it more than 10%? Yes, it is. So delta tells me, delta is confirming what P is telling me. Both of those measurements are telling me that this table is statistically significant. But what I really want to know in this second part of the lecture is, how much effect does sex have on your attitudes towards capital punishment? And delta is telling me it's about 12%. Sex accounts for maybe 12% of that difference between men and women. Again, this is a naive way of using delta. You would not use it that way in a graduate statistics course, but I think for beginning sociology, it's acceptable. It's just a simple number that we can use to measure the difference between the categories of our independent variables. So here our independent variable is sex, male and female are the categories. How much difference is there between them? About 12%. That's what delta is saying, about 12%. So we can quantify how significant our independent variable is. How strong is its effect on capital punishment attitudes? Part C, data analysis is not an exact science. Analysts always need to use their own judgment. It's rare that two analysts will do things exactly the same way and get exactly the same results. Here's a table I made for you from a survey called the National Survey of Adolescents in the United States. It was conducted back in 1995. And we're looking at the percentage of people who've been involved in gang fights. Remember, these are teenagers. And gender is our independent variable. So 8% of the male teenagers have been involved in gang fights, only 4% of the females. So if we calculate delta, we get 4%. So is this table statistically significant? Is that a significant difference? Well, it doesn't meet my rule. It's not greater than 10%. 4% doesn't sound like very much. So if we followed the rules that I've given you so far, I'd say, A, this is not a statistically significant table, and B, the difference between men and women is not very much. However, let's think about this. Being involved in a gang fight is a rather rare thing. Very few people are involved in gang fights. Another way of looking at this table is to say that the males are twice as likely as females to have been involved in gang fights, 8% versus 4%. they're twice as likely. Now, if you say it that way, it sounds like a big difference, right? If I say there's only a 4% difference between men and women, it sounds like not very much. If I say that men are twice as likely as women, now it sounds like a lot. It sounds significant. So which interpretation is correct? Is it a trivial little 4%, or is it twice as much? Well, they're both correct. And if you're an honest analyst, you probably should report it both ways and think about it and think about what's really important. In this case, where you have something that's fairly rare, maybe that 4% really is meaningful. Even though it's a small number, it still is twice as much. You're not going to get 10% differences with something that doesn't happen very often. You know, if something that only happens 1% of the time, then you're not going to get a 10% difference between men and women. But if the men's result is twice as much as the women's result, maybe that tiny little difference really is meaningful. So these are things we need to think about. Now you might be asking, well, why can't I just have a rule and do it the same way every time? Well, I have given you some rules, but I just want you to know that those rules do not always work. And when you leave this class and you become a consumer of statistical research, you should keep these things in mind. There's a lot of judgment calls going on in any data analysis project. You should always be thinking about that. Use what you know about data analysis to evaluate whether you want to trust whatever story that somebody is trying to tell you with numbers, because you should know yourself that it's easy to look at the same table, this one I have here on the screen, and read it in two completely opposite ways, trivial 4% versus twice as much. Now, if you had to do any recoding when you've done your own research projects, you probably realize this. For example, one of our classmates was looking at income, the difference between a high income and low income. Well, where do you make the cutoff? How much income do you have to have before I consider you a higher income? How much do you need to be considered middle income? How much do you need to be considered low income? Well, as a researcher, you get to decide, and different researchers will decide different ways and make different categories. Now, if there's a standardized way of making those categories and everybody agrees on it, then you should do it that way. But most of the time, there's not, and you get to decide, and everybody is going to do it slightly differently. And this is a opportunity for dishonest researchers to try to sell you a story and say that it's backed up by evidence. So again, keep this stuff in mind. Okay, so let's recap this lecture and the previous one. You've looked at two ways of assessing significance. One is statistical significance, which means the probability that our results are not due to randomness. And then we've looked at substantive significance, which is the difference between the categories in our independent variable, in this case sex. Is it real and meaningful, or is it small? You can have a small difference that is statistically significant, but probably you shouldn't care about it. Okay, statistically significant, but it's so small it may not even really matter in real life. So we want to look at significance from both perspectives, and that's what you should take from this lecture. We'll be doing more of this as we move through the semester, so make sure you've taken good notes and you understand this stuff. You will be seeing it again.